Scientists have found the beginnings of a young universe that may offer insights into the beginnings of our own Milky Way. Jeff Bennett talked recently with Miles O'Brien about why scientists are so excited by this discovery, one that has a little holiday sparkle of its own.
NASA's James Webb Telescope recently detected an image of a young galaxy that formed 600 million years ago after the Big Bang. And that has a mass much like our own galaxy did at what you might call its infant stage. Scientists have nicknamed it the Firefly Sparkle Galaxy because this image of star clusters reminded them of a swarm of lightning bugs on a warm summer night. And appropriate for tonight's conversation, one British researcher said the image also reminded him of Christmas lights strung together, with its 10 densely packed star clusters embedded in an arc of stars. Our science correspondent, Miles O'Brien, is here to deck our halls with these Christmas lights in space. Miles, happy holidays. Always good to see you. So help us understand more about this Firefly Sparkle Galaxy and why it's so important.
Well, Jeff, if you could imagine a baby picture of our own galaxy, the Milky Way, this is probably what it would look like, according to scientists. This is a galaxy that is about 600 million years after the Big Bang occurred, about 5% of the time into the formation of the universe compared to today. It has the equivalent of 10 million suns of mass, but that's considered a low mass galaxy in the grand scheme of things. It is filled with these globules of stars that are forming 10 clusters in all. And the difference in light has a lot to do with the fact that they are happening at different times. The light temperature changes depending on where you see it in time. And so what it is telling scientists is an awful lot about the early formation of things like the Milky Way galaxy in ways we have never seen before. The James Webb Telescope has the ability to see much farther and further than we could have imagined with other telescopes.
Well, tell us more about how it was discovered.
Well, James Webb does its business in the infrared spectrum, which allows it to see deeper in time as objects move away from us as they are post-Big Bang. They move into the infrared spectrum, and you can't see them with visible light telescopes. So that's number one. Number two, James Webb, because of that capability, can see through very thick dust clouds, and that's how it was able to resolve all of this. But in addition to that, it used a trick borrowed from nature itself. As they were looking toward this particular Firefly Sparkle galaxy, this cluster, they were looking through yet another formation which bent the light from Firefly Sparkle. And what that does is it focuses the light, not unlike a magnifying glass, in a way that allows the telescope to get a free assist from nature and see the focused light more easily than it would on its own. So it's a combination of a fabulous telescope in space that works in the infrared, using a trick, the bending of light by virtue of the gravitational pull of a galaxy to focus the light better so we can see it.
Fascinating. It's called gravitational lensing. Is that right?
Yes, gravitational lensing. It's kind of a free ride for a telescope. It allows it to see a lot deeper, and scientists are just thrilled that James Webb has been able to sort of extend its reach by doing this.
And we could not, or scientists could not do this kind of work were it not for the James Webb Space Telescope.
Yeah, it's been in orbit now for 3 years. This is one of the big findings for James Webb. You know, to go back in time as it does to 600 million years after the Big Bang and really see, the formation of stars and their companion galaxies is an extraordinary feat. I mean, you can't go back much further because after the Big Bang, Jeff, there was an opacity to the universe. No light got through. And so this is really very early days. We're getting to the very edge of capability for seeing anything. And so pretty much every time they turn on the James Webb and point it in some direction, it's a new discovery. And this one is right up at the top of the list. They have found something that goes even further back in time, 250 million years after the Big Bang. But this particular finding has really intrigued scientists because it offers them up a view of a really chaotic and yet also creative time for our universe.
Only 250 million years after the Big Bang? Well, what does...
It's a blink of an eye.
Yeah.
It's a blink of an eye.
Well, what does the Firefly Sparkle Galaxy teach us about the early universe?
Well, this is getting into deep origin ideas here. It allows us to imagine the very origins of where we come from. This idea of, what was the Big Bang and how did the universe form? We're getting down to some really fundamental data, which gives us some really clear answers as to how everything around us formed. It's an extraordinary moment in science. We're very lucky to be alive at this moment to really have this kind of insight into where we came from and how it all happened. One of the big questions that maybe James Webb will get us a little closer to is this issue of dark matter. This is still yet undiscovered by scientists. They know it's out there because they know the gravitational pull of these planets and stars and how they interact with each other indicates it has to be there, but we still don't know what it is. So who knows? Maybe James Webb will answer that final big question on dark matter and lead us ever further to greater understanding of the universe and why we're sitting here talking and enjoying the holiday today.
Yeah, one can hope. Miles O'Brien, always a pleasure to speak with you. Merry Christmas and happy holidays.
Happy holiday to you, Jeff.